So I welcome you all to Android Jam Session 4 and let's get started right away. So before every session, I'd like to just introduce you to all the things that you need so as to cover the syllabus and some of the requirements or some of the prerequisites that you need to have before we start off with the session. So I'd be just showing you a few slides about the prerequisites that you need to successfully also code along with me for this session. And also we'll be looking at the syllabus. So we'll see how much we have finished until now. So this is generally the common slides that I generally show before every session. So let's get started. So like in every session, we have been mentioning, so these are some of the equipment that is needed for each student. So definitely you need a computer, you need an internet connection and an Android device and a USB cable. So this is an optional requirement. So in your Android device, for example, let us just assume that you don't have the virtual emulator with you. Suppose you don't have the virtual emulator with you, you can also use your Android device and the USB cable so as to run the particular program on your Android device. Basically, you can even debug your entire code. And once you finish the debugging and once you want to test your application, you can basically test it using a USB cable and an Android device that is attached externally. And it's really simple to do it. You just have to configure the settings in your phone, and you would be easily able to connect it to the Android Studio. So that is something if you want to try it out. And then you'd need Android Studio as well. The installation of Android Studio is very straightforward. You just need to go to the Android Studio page and just install Android Studio from there. So this is the IDE. You can imagine this to be the IDE where we would be writing our programs, where we would be writing our business logic basically. And we would be also discussing how to write them. We'll be discussing more about Kotlin and how to write Kotlin functions and what are the important tasks. So that's about Android Studio, requirement of Android Studio. And yeah, just in the previous slide, as I was mentioning, one of the important softwares that we would be using all throughout the sessions is Android Studio. We had been using it and we had basically created many applications using Android Studio. So we had built many Kotlin apps until now using Android Studio. So this is the official tool to build Android apps, and the installation of this software is also really simple. You just need to go to their website and just click the download button, and it downloads for you. So that is the software requirement. And also you can install something called the Android emulator. So when you install Android Studio, you'd also get an option to install the Android emulator option also. And once you select that, what happens is that an emulator is also being installed on your machine. So emulator is nothing but a virtual phone that would actually mimic your real device or the external device that you connect via the USB that we talked about a few slides back. So for running the program, you can either use probably an external USB cable and connect it to an external device, or you can basically install an Android emulator, which comes with when you install Android Studio. And once you have the emulator in place, it is really simple to run all the programs. So this is another feature that Android Studio provides its developers. And basically, using this emulator, you can test all your applications, you can debug them, you can see where you're facing an error, or when we talked about views, right? When we talked about the activity underscore main.xml, what are we bringing there? So we are bringing all the text views, we are bringing the edit text views, etc. recycler view, and so many other things we are just dragging and dropping into our playground. So you can basically see where your elements are. So if you want a particular element, say a button, to be exactly fitting in the screen with a certain dimensions, the Android emulator would help you to do that. So it would basically tell you how that button would basically see or look when you actually run the application. So when you run the application and when the application is in testing phase, you can see the exact place as to where you need to put your text views and buttons and so on, and you can adjust them accordingly as well. So that is the use of the Android emulator that I would like to add here. And like we talked about in the previous slides, these are some of the prerequisites that you need to know before you actually jump into uh, programming in Kotlin. So you need to know, you need to have a basic computer literacy, you need to have some basic mathematics skills, computer and headphones, internet connection, Android device and USB cable. This is if you're using an external Android device to run your entire program, or you can just have an Android emulator with you. So in my computer, we are using the Android emulator itself. And the learning objectives are these three. So you'll be building your first Android apps. You have built your first Android app in previous sessions as well. And as the sessions are progressing, you'll be able to build more complex apps. But nevertheless, you would have built your first Android apps throughout this entire session. So throughout this entire series of sessions, you could have definitely built your first Android app and then set up Android Studio on your computer. So we discussed about the downloading of Android Studio a few slides back. So that is what the second point is telling us, and learn the basics of Kotlin programming language. So we have already learned a lot about Kotlin programming language until now. We have seen life cycles, we have seen recycler views, we have dealt with views, we have made a program which accepts user input and basically does some calculations and display it on the screen. We have also dealt with lists, the importance of lists and what lists are and what it can do, how to store elements in a list. We have discussed all these things in the previous sessions. And all these things only comprise of the basics of Kotlin programming language. So you have learned enough basics about Kotlin, and we'll still be studying a bit more about Kotlin. We'll be understanding various functions. We'll be looking at coroutines today. We would be studying a whole lot of other things today. So that's about the last point. So you would have learned the basics of Kotlin programming language by the end of all these sessions, and also you would be ready and confident to build your own app using Kotlin. So these are the things that we would have learned by the end of the all the 5 sessions. So we have seen the introduction, we have created our first Android app, we have seen the layouts, how to add button to an app, and basically we are using all these concepts. We have made an app that is the calculator app, which does the addition operation. We have seen that also. We have seen to how to get the user input. So if the user inputs two particular numbers, basically the operation is to add and display whatever is the result. So we have seen that as well. And not only that, we have also dealt with displaying a scrollable list. So scrollable list we have taken into detail, and we had discussed about how the InShots application is basically displaying news. So they are basically using a scrollable list. And we had also seen the implementation of recycler views in that. So what exactly is a recycler view, how it is being implemented, and how we are able to display different components. We are able to display different elements as well in the when we open the app. So we are able to display the pictures, we are also able to display the headlines and then content relating to that headline. So we have discussed all of these while we were discussing scrollable lists and recycler views. today we'll be looking at a bit into navigation. We have seen actually navigation in the previous class session where we have basically seen what navigation means, and we have also studied a little bit about navigation. We have seen the introduction to it. And today we'll also see some of the architecture components and some other advanced navigation examples. So we'll actually be making two apps today. We'll be showing you two apps today, and we'll also be discussing in detail how all these things are working in unison, and we'll also be running the apps for the same. So coroutines is another topic that is also really important, and that would be discussed today as well. So coroutines, and we'll also be introducing you to what HTTP is and what REST is. So HTTP and REST are again two important concepts that you need to know. Basically, uh, you know, you are actually retrieving and displaying images, etc., from the internet. So you need to know what are the protocols, underlying protocols which help in fetching information from the internet and displaying it to you on your screen. So HTTP is a very important concept, and REST too. So what exactly is REST? What exactly is HTTP? How are you retrieving information from the internet, etc., will be dealt. And this is coming to the last part of it. We'll be introducing you to SQL, Room, and Flow. So if you want to store this data, once the data we have, once the data you have, you want to store this data and you want to basically perform some operations so as to get some useful results out of this data. So that is what would happen when we discuss about Room and Flow. So how are you storing it and how are you manipulating that data so as to get some useful result from that entire operation. So that is about introduction to SQL, Room, and Flow, and scheduling tasks with work manager and using Room for data processing. So these are again two other topics that would require a little bit more insight into it. So we'll be dealing with that when we reach that portion, that is in the next session. For this session, what we would do is we would be basically seeing about coroutines, we would be seeing about advanced navigation components, and we'll be basically making two hands-on apps, and we'll go through them in detail. So that is about the introduction of this session, and now we'll simply jump into the concept. So app architecture, I would like to first introduce you all to something called app architecture. So architecture basically provides you with the guidelines to help you to allocate responsibilities in your app between the classes. And what the first point basically says is, the first point is saying before you have an app, before you build an app, or before, let us say, in real world you're building a building. So before you build a building, you are basically having a blueprint about how the building is going to appear. So once you have the blueprint, you would be basically making a drawing or a sketch which would mimic how the actual building would look. So before the construction, you would basically see the land, you would see the plot, and then once the plot has been decided, the foundation stone is laid on that plot. And once the foundation stone is laid on that plan, you're going to come up with a blueprint. So that's what basically architecture is also about when you're taking Kotlin applications into consideration. So before you build your mobile application, what you would do is you would have a high level or an abstract level idea about what are the architectural components. So how you want to architecture your app, how do you want your app to behave. So all these things are basically discussed in the app architecture, which is an important step as well. So in software engineering, so when you take software engineering products, so you have a lot of planning that goes into place. So before the app is built, you have this step called a requirements elicitation, where you basically list down all the requirements that you need to build an app, so or that particular software product. So these are some of the important things that you need to know when it comes to app architecture. So a well-designed app architecture helps you to scale your app and extend it with additional features in the future. So what the second point means is, if you have a well architectured app before you start building it, it will help you to scale your app. So scaling is another important property, and scaling basically means you are making the app available to many people at a time. So when you take scaling, again there are two types of scaling, that is horizontal scaling and then vertical scaling. So horizontal scaling is when you have the app and you want to basically scale it to so many people at the same time. So that aspect is um, horizontal scaling, and vertical scaling is when you basically increase the power of the app. So you want to basically increase the power so that, or the functionalities you can say, so that it is being accessible by more people at a time without any change in the behavior of your app. So that is what scaling concept is all about. And that's what the second point says. So if your app is well architectured, it helps you to scale. So scaling need not be only horizontal scaling as such, even vertical scaling. That's what the second point says. And these components take care of some of the complexity of the life cycle and help you to avoid life cycle related issues. So we saw what exactly is life cycle, and we discussed about the entire Android app life cycle as well, how the cycle goes from one state to the other state. And we also saw that if there is another application, we saw how priorities are assigned and what happens when a particular app is running on the background, what steps it goes through, and we also saw the entire life cycle in the previous slide. So this is about app architecture. But to just give you a small or a short recap about what I talked in the app architecture, we basically saw that before building the app, you would basically design a basic level architecture so as to plan how your app would be once the app is being basically deployed on the Play Store. So that is about app architecture. Just like how you make a blueprint for a building, you would basically have a particular architecture. So you would basically write down where the data would be stored, where how the data would be displayed on the screen, etc. So all this planning basically constitutes of it. And the advantage of that is once you have a well architectured app, it helps you to scale. And scaling here basically even includes horizontal scaling and vertical scaling. So that's what we talked about in the first slide. Moving on. Now we have view model. And view model is a model of the app data that is displayed in the views, models and components that are responsible for handling the data for a particular app. So again, when you take InShots as an example, so we can kind of imagine what importance does these models have in them. So you can see how important are these components that are residing in them. So you want to basically give out the very recent news happenings to your applicants or the people who are going to read your app. So they allow your app to follow the architecture principle, driving the UI from the model. So you have all the news articles with the photos, with the headlines and the description about that particular headlines and everything stored in one particular place. And this view model would basically help or is a model of the app data that is displayed in the views. So when you take the views as an example, this would be responsible for handling the data of the app. So how that news article is being fetched and how is it being displayed on the screen. This background work would be basically done by models here. So we'll be looking at how everything is working by taking an hands-on example as well. So that is about view model. And then there are again three in this map, basically what happens is you're showing how you are adding the view model. So you have the main activity. We studied about main activity in the previous sessions as well, what main activity is. This is where you are basically making, we are basically taking that ID, right, from the activity.main XML the file that we saw. And from that activity.main XML, we are basically bringing in design elements into our playground. And this is how view model is basically depicted. So if you are basically implementing a view model, so the hierarchy is somewhat like this. And again, you have a life cycle of a view model as well. So these are some things. And in today's app, we'll be basically building an unscrambled application. So this unscrambled application, what it would do is you would be given scrambled words in your the display, and you have to basically unscramble the word and then type in the word. So once you do that, and if the answer is correct, what it would do is it would award you 10 points. So that is about the app that we would be seeing today. But just to add a few more points about view model so that you become clear about what view model is. The view model basically stores the app related data that isn't destroyed when an activity or a fragment is recreated by the Android framework. So it basically binds and it holds the data, and it can be any kind of data. So in when we were talking about the InShots application that we were taking into consideration, it was basically the view model that was storing the app related data, and view model objects are automatically retained. That is, they are not destroyed like the activity or a fragment instance. So once the activity is over, what happens is that the activity is destroyed, right? That's what we saw when we were even considering the life cycle in our previous session. So what happens in view model is once you instantiate a view model object, again, view model object can be invoked by invoking some of the basics of Java that we discussed about before we started the session. So we basically mentioned that you need to know a little bit basics about programming, and basically you just need to invoke the objects concept in Java. So for this view model, when you make an object and when you instantiate an object, basically what happens is that the objects that are automatic, so the view model objects are retained. So the activity and the fragment instance that we discussed can be basically destroyed, but not the view model objects. And the next point is, again, when you invoke Java concepts, which is really important when we were studying these things. So we mentioned in almost every sessions how important the basics are. So if you want to basically implement view model in your app, you have to extend the view model class. So that is basically in Java achieved by writing the keyword extends. And view model is also responsible for holding and processing all the data needed for the UI. So again, when you take in InShots as an example, so view model would be responsible for processing what kind of data the user wants to see. So again, you have so many categories of news that you want to see, probably be it national news, probably be it international news, so on and etc. So the data for each of these categories is basically packed and binded. So using this view model, the view model has to decide what kind of data it should serve you, or what kind of processing that this view model needs to do so as for the user to see the right kind of news that he exactly wants to see. So that is about view model. So view model is also responsible for holding that data and processing the data. How does it hold the data? It holds the data because when you instantiate a view model object, that view model object is basically retained. So this is about view model. So we understood what exactly a view model is, where it is used, and we compared it with the InShots app where you have a picture, where you have a headlines, and also you have content about a particular headline. We also saw what would happen to the view model objects once they are instantiated. That is, they are basically retained, unlike the fragments and the activities. So this is all about view model. So it will help in processing of the data and holding of the data, and also displaying the data and just coordinating and just working with all the components in unison, so that the end user is able to read the news. For our example, when we took InShot's application in almost every session that we have discussed till now. And how to implement view model in your app, it can be easily implemented by just extending the view model class that we basically studied in Java, if you could recall. So this is all about view model. And just to give you a little bit more insight into what this diagram basically conveys is, you'll have basically you'll have to add a view model to your app, and this view model would be basically storing something called the app data. The data that is related to your app will be basically stored in the view model. So that is what we basically saw when we were taking the InShots application as well. So all the news that would be curated would be stored in the view model of the entire application. Now we'll be basically seeing how to implement the same in the application. So this is something called the Unscrabble app that I would like to introduce you to. And here, what I would like to introduce you to is, I would basically like to show you the game fragment.kt. So we studied about what game fragment is. We saw that game fragment can be destroyed. We even saw that the activities can also be destroyed, but not the game fragments. So here what I'm doing is, we are basically first making Kotlin file called gamefragment.kt. So this is our Kotlin file called gamefragment.kt. And we also have another file here that is of importance when we take this application, and that is gameviewmodel.kt. So these two are some very important things that I would like to show you. And like we discussed in the slide, before using view model, that view model has to be basically imported into your application. So the task of importing is basically done in line 3 and 4 in this Kotlin file. So as you can see, you are basically importing Android X.lifecycle.view model. So how to basically see or understand this dot notation, we have basically seen in the previous sessions as well, where we discussed that once you have a library, you go to a particular section, say biology section, and you want one particular book, or if you go to the physics section and you want only one particular book based on, say, laws of motion, so you go to the library dot physics dot laws of motion. So this is how you're going to basically access one particular element from a huge library, for example, when you have so many classes within that particular library. And this is about it. So if you go to the Gradle scripts folder, and if you see the Gradle scripts folder, you have build.gradle and you have the module, etc. And if you go to this particular file called build.gradle module unscramble.app, what would be here is, you would see something called the dependencies. So dependencies are something that you really require while running your application. So here is where you'll find a list of dependencies that are required while you're building your application. So when the application runs, so these are some of the minimum standard requirements that are required. So you need to have a min SDK version of 23. The target SDK version is 31. So basically what it says is, while you're building your app, you need to have so and so as the minimum SDK version, so that this particular Android app can run on your device. And the most important thing that I would like to highlight here is, here in the dependencies, basically you are using this. So this is where you're using this view model. So you are, first of all, before using it in your entire application, what you're doing is you're writing the keyword that is implementation, and then you're saying Android X dot lifecycle view model. So we saw what was lifecycle in the previous sessions, and here is where you're adding the dependency. So once you add the dependency called view model into your application, only then you can basically include that view model in all your Kotlin files. This is called the library dependency. So once you have the library dependency, and this is the version number, 2.3.1 is the version number of it. And once you have the dependencies all in place, you can basically start using view model into your application. So once you want to check that particular view model is present or not, it is really important that you navigate to your Gradle scripts and you go to your build.gradle file. And here you would be seeing other things as well as we discussed. So this is about where and how to bring in view model into your application. So this is how you would bring it. And now you would basically you can start using the view model. So here, as we can see, you have this class called game view model, and this class game view model is of the type view model. So again, if you want to use this view model in your Kotlin folder, what you would do is you would basically import it from this build or Gradle. So from the library, you would go and import this view model that we discussed. So that's what is happening in line number 4 here. And now you have a class called game view model. So in this class, basically you're basically making a variable called score, and you're initializing that score to 0 initially. And these are some of the things. Before you actually get into starting to code with this, you need to know something called the life cycle of a view model. So even view model comes with a particular life cycle, and the framework that keeps the view model alive as long as the scope of the activity or fragment is alive. So this fragment that we are talking about keeps this view model alive. So until and unless the entire application is finished, this framework keeps the view model alive. So once the view model is finished, you can't basically perform much task. Now, what we are doing here is we are now basically making some variables here. So current word count is one variable, score is one variable, and here an important method or that we need to discuss. So we discussed about life cycles in the previous sessions, and init is one of the important things that we need to discuss here. So Kotlin basically provides an initializer block. So the thing that comes under this init is the initializer block, and in this initializer block, what happens is you are logging the game fragment. So log is nothing but if you want to see the logcat operations here, once you debug the program, you wanted to see what is basically being displayed in the logcat. And in the logcat, what is happening is you're basically displaying the game fragment. So this message would be basically printed, and this function called get next word, what it does is it tries to get the next unscrambled word and display it on the screen. So that's what would happen. So whatever is written under this init block would be basically run once the initialization of the entire application happens. So this is about the init block. Now you're basically the next step is you're going to basically populate the view model. So we have basically discussed about what view model is, how to create it, how to make a class of it, how to import it in your Kotlin file. And now when you're basically using it, what you would do is you have to populate it. So while populating it, when you declare a variable, you have to provide it with an initial value upfront. So when you basically create variables in Java or Kotlin, you are basically even giving that variable a name. So that's what is happening here also. And to late initialize a property in Kotlin, you're going to use the keyword late in it. So after a particular amount of time, a fixed interval of time, if you want something to be displayed, it basically comes. You can do that particular operation using this late init keyword. So that is about this late init keyword. And once you go to the game fragment.kt, here what is happening is initially you're basically importing the view models that you need to import. You're also importing the fragments that we talked about. They are basically destroyable. Here is where you have the class fragment. And in this class fragment, what you're doing is binding object instance with access to the views in the game.fragment.xml. So if you see the game underscore dot xml, what you have here is you have basically the design. So when you go to the design of whatever is basically printed in your Android screen, you have it in code over here. That's about this Android underscore fragment.xml. So if you go to your design, you can see how the things of your Android projects are basically laid out here. So you have the scramble word and then you have some description. You have the counter here, which basically says which word of the 10 words you are basically at, and you have two buttons here. And instead of just bringing them and dragging them to the screen, you can basically code the entire thing as well. So this is what is basically written there. So that is about the game.fragment. And here the class game fragment, what it does is using this fragment keyword, you would be basically having the view model and you're basically using this fragment, you're trying to access some of the objects from the game underscore fragment.xml. So you're basically binding it here and set on click listeners and get string and these functions, what it does is once you click that, so there are set on click listeners. We again discussed this in session 1 or session 2, where we discussed about once you hover around a particular element, how should that element behave when you are basically clicking on it. We saw about how that particular button, that is on click listener, buttons will be basically given an on click listener, where if you click on that particular button, what would happen is it would listen to that event, and once it listens to that event, it kind of makes a decision about what to do the next step. So this is what is being told in the comments as well. So you're setting up a click listener for the submit and the skip function. So when a particular user presses on the button skip, or when the particular user presses on the button called submit, what would exactly happen? So that is about the submit and the skip part of it. And then updating the next word on screen. So updating the next word on screen is one function where once the listener listens to the event, the listener is also going to take a particular action. So once the listening is done, the next step would be to perform a particular action. So that's what the action is being performed here, and that action is this function, that is update next word on screen. So it's going to update the next word on screen. So that is what basically is the business logic that we write here in the game fragment.kt. And there is another thing that you need to write called helper method. And while we were talking about this view model, if you go to your game view model, you have something called the helper method here. The helper method is basically given here in this next word function. So when you have this function called next word, it is basically of the type boolean, which means that this function should return a boolean value. Either has to return a boolean true, or either it has to return a boolean false. So this is about the next word function here. Once the function does a particular operation, and if the particular operation is evaluating to true, it would give true, else it would give false. So that's what the business logic that is written here explains. So return if the current word count is less than the maximum number of words, it would get the next word. Get next word is basically performed here. which means that get next word function is basically called in this particular file. You have other functions as well, like increase score, is user word correct, etc., etc., which means that if the user is actually guessing that word to be correct, then a particular operation would happen, else another particular operation would happen. So this is again a function that is returning a Boolean value. So this is all about this application that we were seeing. So the aim of this entire application is to basically write down an application which would help you to understand how view model is being implemented in your entire application. So just to summarize everything and to finish everything, we saw what a game model, view model is, and how to basically import your view model. If you go to your build.gradle, these are the dependencies, and dependencies are something that you need to import for your application to work. So in your libraries, you have something called dependencies, and when you import that, it basically sits in the dependencies. And if you want to introduce view model into your application, what you would do is you would import that using by writing this keyword called import, and you would basically import it from the life cycle. So we compared this with the library scenario. So that is all about what view model is, and you can as well run the application. Once you run the application, the Gradle build starts running, and once the Gradle build starts running, you can see the output on your screen. So the current output you're seeing is a cupcake output, which means that the state has been not cleared and the cache is not being cleared. Once the cache is being cleared, what happens is the newest program is loading. So as you can see, the launch also actually succeeded, which means that the build was successful, which means that all these scrambled words that you are seeing, if you hit skip button, the on-click listener is being also being invoked, and these are some of the words you can probably guess, and you can write it here. And once you hit submit, it sees whether your words that you are submitting is the right word. If it is the wrong word, you would not get any points, and if it is the right word, you would get uh, 10 points. So this basically is alpha, and you can write the word here and then just click submit. And once you click submit, and if the word is correct, what happens is it would basically also update the score over here. So tasks are something that is again really important. You can basically think of this as tasks that we perform on a regular basis. So we perform many tasks on a regular basis, be it when you open the Android app for the first time from the launcher icon, the Android creates a new tasks with your main activity. So a particular application is run on your Android Studio. Basically, not one task is performed. It basically is a combination of so many tasks or so many things that are happening in unison. So that is what tasks are all about. As you can see in the next point, as it says, the task is a collection of activities that the user interacts when performing a certain job. So each and every activity, when you dissect your entire application into so many lists of activities, each activity can be given a task, a unique task. For example, checking an email can be given a unique task. So again, when you take into consideration the app that we were discussing for all this while, that is the InShots application. So we can basically define so many tasks in our InShots application. So one of the tasks would be to open the application once. That is one task, and then you are basically given so many um, different kinds of genres of news that you want to read. It can be about, say, national news, it can be international news, it can be sports news, it can be some news around the world, etc. So again, bifurcating that into so many other different modules is another task that we are performing. And activities are arranged in the stack known as backstack. So when you are actually navigating through an Android app, you perform many activities, right? And each activity basically has a state arranged with it. And each of those states are basically arranged in a stack structure. So uh, just to remind you about Java basics again, so you need to know what exactly a stack is and how a stack is working. So stack basically is following the first in, last out structure, which means FILO. So once you insert an element in the stack, you can get back that element only if you move the rest of the elements that are present above the stack. Only then you can remove that element from the stack. So this is some basic data structures that you need to know. You can think of stack as a stack of pancakes where each new pancake is added to the top of the stack. So if you want to basically access the pancake that lies at the bottommost position of your stack, you have to first remove the topmost layers of the stack, and only then you would be able to access the bottommost layer once you put or start adding activities into your stack. So this is how it is basically organized. So this is called the back stack. So once you finish activity one, the state is saved, and then you go to activity two, you start performing another activity. So for example, let us assume that you're initially reading some news about one particular thing and that activity is over. So you started reading some other news from some other genre. So that is another activity. And you have a third activity and you're doing that as well. So that is about the number of tasks that you're doing. So all these tasks can be arranged in a stack. So if you want to come back to activity one, you have to start from the top of the stack in order to get to the activity one. So that's about tasks. And now I introduce you to something called coroutines. So coroutines is nothing but an instance of a suspendable computation. So suspendable computation is nothing but something that can be assumed to be particularly working, which is similar to threads in Java. So it may suspend the execution of one thread and resume in another one. So how coroutines work is you can basically think of working of coroutines to similar way in which threads work. So threads also have a similar way of working. So once a higher priority thread is coming, what happens is the the action that is currently being performed is finished and it goes to the next action. So that is about how threads are working. And however, coroutine is not bound to any particular thread. So in thread, what happens is after an execution is completed, it goes to the next thread. But here it is not the case. You can again basically compare this to tasks in which the scheduler is basically assigning those tasks. So if you could recall, then scheduler would basically, if a high priority task is coming, and if the scheduler is executing a low priority task, then a particular concept called context switching happens. So these are some of the basics that you need to know. And I'll finish off the lecture today by just introducing you to HTTP and REST. So HTTP is a protocol that allows you for sending documents back and forth on the web. So you can think of HTTP as the heart of the web. So HTTP is nothing but hypertext transfer protocol. And protocol is a set of rules that determines which messages can be exchanged and which messages are appropriate replies to others. Uh, so this is another thing. So when you're basically communicating via the internet, a whole range of protocols are basically needed so as to set a standard of how you would be sending messages from one place to source to destination. So that is about HTTP, and this HTTP has a list of rules. So it's like a protocol which basically governs the transmission of messages from source to destination. In HTTP, there are two different roles, that is server and the client. So server basically responds to the client. So if the client request for a particular service, it sends a HTTP request to the server. And once the server basically gets the request from the client, the server basically replies back to the client with the appropriate response. So this is about the server client server model in HTTP. REST is a simple way to organize interactions between independent systems. So REST is one, again, a very important thing to know what REST is exactly. So after the initial overview, so until now, what we talked about is we talked about how we are basically sending and receiving information via this protocol called HTTP. And if you see the second point here, it says it's been growing up in popularity since 2005 and inspires the design of services such as Twitter APIs. So API is something that you need to know. So API basically stands for Application Programming Interface, and this is nothing but like a waiter. So you can basically compare this with a waiter of a hotel where if a customer basically comes into the hotel, he's given a menu card, and once he orders a particular dish, the waiter goes to the chef and gives the list to the chef. And once the food has been prepared, the chef basically gives it back to the waiter, and the waiter basically delivers that particular dish to the table. So this is how it happens in restaurants. And similarly, you can even basically compare the work of an API. So the work of an API is nothing but to take the request from the client and process the request and serve it back to the client. So once the server responds with a response message, acknowledges the message, acknowledges the request, the server is going to ping back with a response. And this is due to the fact that REST allows you to interact with minimal overhead with clients as diverse as phone applications and other websites. So there is minimal overhead, and basically for effective communication, you want to reduce the overhead on your particular system. So REST does that. And so this is basically about REST. So just to summarize the whole concept of what REST does, you can just think REST as a simple way to organize the interactions. So whatever interactions were happening, uh, it's a good way to streamline the interactions. And REST basically stands for representational state transfer. So this is what it is all about. So it is an architectural style again. You can kind of imagine REST to be an architectural style, which basically streamlines the communication. So this is about REST. And why do people use REST is it provides a lot of flexibility. So REST also can handle multiple kinds of calls. So it can handle multiple calls. It can even return from different data formats and change structurally and change dynamically, because you would be dealing with a lot of data formats when you are dealing with complex applications. So this is about REST. Sure, Vamsi. So I think we have a question from Vamsi. So he's asking how exactly REST is used. So I would give the answer. So basically, REST APIs are basically used, and when you talk about REST or when you talk about a RESTful API, you have to take so many things into consideration. So you have the client server model that I previously talked about. So in the client server model, what happens here is the client is basically talking to the server. So when the client talks to the server, uh, the client basically sends a request to the server, basically requesting for a particular resource. Now, what happens is the the server basically accepts first, acknowledges that request, and it has to respond back. So REST API is an application programming interface. Before that, it's basically an architectural constraint. So it is not a protocol or not a standard. So that is something to keep in mind. And how it basically achieves it is it uses something called headers and parameters. And headers and parameters are something that is really important when you take into consideration HTTP methods. So we talked about what HTTP is, Hypertext Transfer Protocol. So that is about it. And now basically what you have is you have again REST is nothing but again a set of guidelines that can be implemented as needed. So if you have a set of guidelines that you want to implement, so again to go a little bit more deeper into your question, so when a client request is made via a RESTful API, what it does is it transfers basically a representation of the state of the resource to the requester or endpoint. So the requester or the endpoint here is the server here. Now, how this information is basically delivered. So this is another thing, and the methods. This information or representation is basically delivered in one of the formats via HTTP. So we talked about HTTP about this request sending, right? So it can be basically in the form of JSON files. So JSON files is most generally the popular file format to use because again in JSON basically stands for JavaScript object notation, and in this JSON files what is happening is the values are basically written in key value pairs. So the information here is in key value pairs. So that is about JSON and how it is exactly working. So again, REST API is again something called representational state transfer API. So um, the next doubt you're asking is what exactly a REST API is. So what exactly a REST API is? So we talked about all these REST functions, right? And an API basically or an application programming interface to perform all these REST functions that we talked about, like all the things that we talked about till now. It's basically an API to basically achieve that particular REST function. So again, we talked about what an API is. API is basically an application programming interface. So it's a set of definition and it is a set of protocol for building and integrating the application software. So I hope I cleared your doubt. Okay, so your next question is how an API is basically implemented. So again, to understand how basically an API is implemented, you will need to know how it's working first. And how it is implemented is you can basically think the implementation of basically what you would do is you would move the code from the JUnit tests into the APIs and then uploading the tests. So once you upload the tests, you can actually call those APIs. So if you want to keep testing about what the API would do and what the response you would get, there are so many applications out there. Definitely you can learn it. What I would do is I'll provide the resources for you to understand how APIs are working and how to implement an API in the WhatsApp groups.